Oh, we were right here. So let's try this. This is actually an old test question. Uh, I have this projectile. I'm launching it with a certain speed. Uh, it doesn't do the full trajectory. It comes up and then it lands on the cliff. Strike A at point A right here, which is 2 seconds after launching. Find the following. So let's change that time. I think there was a mistake that I changed. Oh shoot, what was it? Hold on, let me figure it out. I forgot this. I think the time might actually take it below the cliff. Let's see what the total time is. So 0:37. No, I think that'll work out okay. Let's go ahead and try it. Should be a pretty easy problem because you have the time. Okay, if you don't have the time, it becomes a lot more complicated. But I want to know the height of the cliff, the speed of the stone at impact, and then the maximum height above the ground. As soon as you get part A, let me know. As soon as you get the height of the cliff. Actually, guys, I do have a note here that I changed this to 3 seconds. I'm sorry if you've already worked with it too. We're going to change this to 3 seconds instead of 2. So just where you had 3, please insert 2. Or where you had 2, please insert 3. Does anybody have the height? Yeah. Okay, yeah, that's right. So to find the height, since I know the time, I can just take the y function, the displacement function, equals y naught plus v naught yt plus 1/2 ayt squared. That's 0 plus v naught is v naught y. Let's see, it was 30 meters per second. Is it cosine or sine for y component? Yeah, so it's sine of 50. And then times t, 3 seconds, plus 1/2 of -10 times 3 squared. And that gives me my time, it was 20, or my height, which is 24 meters. So this point right here is 24 meters above where it originally hit. All right, if you want to know the speed of the stone, you need to find the x and the y components separately of that speed. So remember our way that we find the velocity that v equals v naught plus at. You have to find the x, and then you have to find the y components, and then you have to find the magnitude of those two vectors. You find the x and the y component of the final velocity, and then you find the magnitude of the final velocity. Does anybody know the y component of the velocity? Josh, do you have it yet? The y component at 3 seconds? You don't have it yet. Brandon, you have it? So you want to first find the y component. Use Pythagorean theorem to find the resultant. I have the y component of the velocity. Yeah. Courtney, you have it?
22.
Sorry, Courtney, what do you have?
22.9.
Is that the y component?
30 sine 50.
Uh-huh. No, that's the y component of the initial velocity. What's the y component at 3 seconds? You have -7. Alright, so that's 30 sine 50, which is the y component of the initial velocity, minus 10 times 3. What did you say that is, Chase? 7? -7. Alright, and then I also need the velocity in the x direction at that point. That's just going to be v naught cosine theta. That's 30 cosine 50. I don't have that if somebody can tell me what it is. Is it 10.7? So we'll just call it 11. And then we want to find now the magnitude of the velocity. It's going to be the square root of 7 squared plus 11 squared. What is that, somebody? What's that? Is that not right? 30. Oh no, it's 19. Yeah, 19. I just had a mistake there somewhere. So it's 19. So 7 squared plus 19 squared. I get 20. So that is the magnitude of my velocity as soon as it hits. So at this point, it has a velocity vector that's in this direction, and it has a magnitude of 20 meters per second. You could also go and find the direction of that. There's probably nothing after that. And then finally, see what is the maximum height above the ground. What are the steps to find the maximum height above the ground?
You use your equations.
What's that, Courtney?
You use your delta y equations.
Okay, yeah, but we don't know the time first, right? So we first need to determine the time.
Would the time just be half of the total time?
No. Why is it not half the total time?
Because it returns its time.
Right, because it's not symmetrical. So the time that we have when it strikes the cliff is 3 seconds, but it requires more than half of that to get up to the top. Right, so we need to find the time at the top. And how do we find that? Right, so just like we did in last chapter, the velocity at the top in the y direction is equal to 0. So we can say v top equals v naught y plus ay times t top. And then from that we can determine what is t top. 0 equals 30 sine 50 minus 10 t top Does anybody have that for me? $13? No, I don't think that's right. Try again. 2.2. Right, 2.3. So, yeah, depending how you carry your sig fig. So we'll say 2.3 seconds. So that's my t top. I just solve this expression for t. And then if I want to know my maximum height, then Courtney, I do what you said. So I use my y function, v naught yt, t squared. And if I plug in my numbers here, I get 30 sine 50 times 2.3 seconds minus 5, that's 1/2 of 10 times 2.3 squared, and that gives me what? What you got? 40. I don't think so. Try again. No, it's not 41. What do y'all got? Yeah, 26. We'll call it 27. Rounding to 1/6. Alright. Find your mistake. That's pretty basic. That's how much that's from an old test, or you could represent something from the old test. Although, you know, this semester we're covering less material than previous semester, so the test, let's see, what? The next test is on the 6th. So your next test is probably just chapters 3 and 4, maybe. So your projectile motion forms a going greater than that. There's something no problems. Alright, let's see what we have here next. Okay, let's look now at some of those supplemental. Actually, let's answer some of these concept tests. We've done the ones on vectors. Is that correct? Yeah. So these are in the back of your book if you want to follow along there. Just about 10 or 12 more. A small cart is rolling at constant velocity on a flat track. It fires a ball straight up into the air as it moves. After it is fired, what happens to the ball? Did I not get one of these? Came in late. Somebody else got it. Alright, stop in about 5 seconds or so, and then we have a 4, 8, 12, 16. Stop at 110. Still somebody not clicked in, there we go. Alright, so if I have something, and I'm moving at a constant speed like a cart, and I throw it up in the air, that object has the speed in the x direction with which I'm traveling, and so when I throw it up, it goes up, but it continues traveling at the same speed as I'm traveling at, and so it falls right back into the cart. So the answer is D, because it maintains that velocity in the x direction, and it just falls right back where it started. However, now I have a situation where the cart is accelerating, it has a force applied to it, and then you shoot a ball straight up into the air, and then when it comes back down, where does it land? Alright, stop in about 10 seconds at 50. Very good, B is right. So y'all want a joke for that? Why do people never starve to death in the desert? This never happens. Because of all the sandwiches there. Get it? The sandwich is there. You drop a plane from a, or you drop back from a plane flying at a constant speed in a straight line without air resistance to the plane. The package will do what? We had this question actually last time. Recall. All right, I'll stop at 40 seconds. 40 seconds. Okay, B is right, because that package maintains that horizontal velocity. So if this is my plane, it drops a package right here. The package follows this path, but the plane follows this path. And at each point in the plane's path, the package is right underneath. Because they still maintain the same velocity in the x direction. They're still progressing forward at that same speed. It's just now you're adding that additional velocity in the y direction. It's like the two little metal balls. One shoots out and one drops down. It's the same, sort of the same here. Right, from the same height and the same time, one ball is dropped and another ball is fired horizontally. Which one will hit the ground first? Dropped, fired, they do hit at the same time. Depends how hard the ball is fired, it depends on the initial height. I'll stop at 30. Stop it at 30. C is right. Just like the two little metal balls we dealt with. Which ball has the greater velocity at ground level? Dropped or fired? Neither. Depending on how hard the ball was thrown. Alright, I'll stop at 30 seconds. 30 seconds. Oh. Okay, so both of the balls are going to drop with the same y velocity, right? They're both dropping down in the same y direction, the same distance, right? This is the drop fire ball, yeah. So they both accelerate at the same rate in the y direction, but the fired ball has an initial what in the, has an additional what? it has an additional x velocity. So it has this extra oomph out to the side. So when they get to the bottom, now here's one ball, here's another. This one goes like this. This one just goes like this. At the bottom, they have the same velocity in the y direction. All right, but this one has an additional velocity in the x direction. So that's going to give it an extra speed. So B is the right answer. Let's see. Well, when you put C, most of you put C, what were you thinking? Oh, okay. Yeah, that's not what it's asking. So it's asking for the greater velocity. All right, you're right about that. That it does. They do have the same velocity in the y direction, but the one that's fired has that additional x velocity. So be careful on reading the problems. Practice comes with that because a lot of the problems on how to test are similar. But just be careful on reading them. All right, projectile is launched, 30 degrees. At what point does it have the least speed? So that speed includes the x and the y components. Where is it the slowest? Question. Stop at 35. 35. Excellent. We're gonna have to have another joke. Okay, I don't know if y'all heard this one. What did the fish say when he ran into the concrete wall? Damn. Did I tell you all that one already? No, okay. I'm gonna use up all my jokes. All right, which of these punts has the longest hang time? These aren't necessarily kicked with the same initial velocity or the same angle, but which one has the longest hang time? Call 1A, B, C, or they all have the same hang time. All right, 45, I'll stop, 45. Pretty well, not really. So D is the right answer. What motion determines the amount of time in the air? The y motion, right? So if they all go to the same height, that means they're all in the air for the same amount of time. Right, so the y motion, how high it goes determines how long it's in the air. That's the hang time is how long it's in the air. Battleship fires 2 shells at 2 submarines. Their same initial velocity, but they have different angles of their initial velocity. So which submarine gets hit first? Is it this submarine, where it goes up and comes down? This submarine where it goes lower, but it goes a longer distance? Or are they both at the same time? All right, I'll stop at 105. 105. Missing somebody out there. All right. B is right. Why does that submarine, which is further away, get hit first? That doesn't really make a lick of sense to me.
Because it doesn't move as much in the y direction.
Right, so it's not in the air for as long, because it goes to a lower height. Remember the y displacement determines the amount of time it's in the air. And so since this goes to a lower height, it's in the air for a less amount of time. And they both have the same initial velocity, so which one had the larger angle? A had a larger angle. So it had an angle likely larger than 45 degrees. And so it just spins longer in the air, but because it has such a big angle, its velocity in the x direction is smaller. So it just doesn't go as far because its angle is too big, and so its velocity in the x direction is small. I mean, there's the extreme of this, right, where you have it all the way up, then you shoot up in the air, and then what happens? It comes straight back down on you, right? And then you sink yourself. But that's in the air the longest amount of time. Okay. For cannon on Earth, it would follow path 2. If you were on the moon, which path would it follow? And again, A, B, C, D, 1, 2, 3, 4. If you go to the moon, it follows which of these paths? This is on the Earth. Which one is on the moon? Where your acceleration in the y direction is less. Stop it. 1 minute. 1 minute. He is right. It falls at a slower rate on the moon. Its acceleration is less, so it just falls at a slower rate. So it spends more time in the air, which allows it to follow this path. I'll just go this further. Almost done. Spring-loaded gun can launch projectiles at different angles. What will give the greatest distance, the greatest range of these angles? I'll stop at 30. Stop in at 30. C is right. 45 degrees, or whatever angle in that list is closest to 45 degrees, will give you the longest range. Because at 45 degrees, that maximizes your amount of time in the air, paired with giving you the largest x velocity. So it works out that those two are at their peaks, which allow you to get the largest range. They're not at their maximum, right? If you shoot it straight up, you get your maximum time in air. And if you shoot it straight out horizontally, you get your maximum x velocity. But by going at 45 degrees, you pair them up and you allow the longest range. All right, let's try this. So you're trying to hit a friend with a water balloon. He's sitting in the window of his dorm room directly across the street. You aim straight at him and shoot. Just when you shoot, he falls out the window. Does the water balloon hit him? So you're shooting your water balloon in this direction so that you aim straight at him. All right? But as you shoot, he falls. What happens? Does it hit? Does it depend upon the speed of the shot? Does it miss? Is it just impossible, or we just don't have enough information? Not really sure. Whatever.
That's a screenshot of our speed.
Yeah. All right, I'll stop at 130. 130. A is the right answer. So if I shoot this projectile out with a certain velocity, and at the same time this guy begins to drop, both of them are going to fall at the same rate, and that means that as they fall, that they will meet somewhere along the way. Right. But does it matter about the velocity? What will happen if I shoot my water balloon with a bigger rubber band and I give it a larger velocity here? What's going to happen? It'll just hit them sooner. So it'll come out here and it'll hit them right there. Or if I shoot it with a slower velocity, it'll hit them somewhere below where it hit before.
I don't think so. What if the height is not high enough?
Okay, this assumes that you have enough speed for it to actually hit him. So are you going to say that there is no ground, basically? And so he's always falling?
No, what I'm saying is if the speed is not enough, so it will require much height to reach the
I understand what you're saying.
and the height is not enough. So.
Yeah, so this says down here actually that you have to assume that its speed is large enough. What Tong is saying is that if you shoot it at a really slow speed, then this guy is going to reach the ground before the balloon reaches the guy. But we assume that you shoot it with a fast enough speed that that's not the case. Okay? They both fall at the same rate, and so they're eventually going to meet. This is called shoot the monkey. Let's see, I might be able to find, let's finish this and I'll find, there's a YouTube video. I don't have the equipment to do it, but it's kind of cool. Alright, similar thing here. Here, you're on the ground and he's up above, and you aim straight at him and shoot, just like you did before. Just when you shoot, he falls out of the window. Does the water balloon hit him or not? Yeah, you're shooting at Spider-Man. A water balloon. All right, I'll stop at 1 minute. A's the right answer. It still hits. We'll work through a problem now. I'll show you mathematically that it works out. But the same idea occurs, that it falls at the same rate. They both fall at the same rate, and so it's going to strike them. Okay. I mean, we'll work through a problem right now. I'll show you this. So you should have a blank page at the end of this chapter. Let's say that we have that same situation. So I'm shooting a projectile here. My friend, or whatever he is, Spider-Man, is right here. Let's say that this distance is, I don't know, 10 meters. And I'm going to give it a really high speed, just so I know that I have enough speed to get across. So since I'm just making up numbers, I'm going to say it's, I don't know, 40 meters per second. That's pretty fast for a water balloon, right? That's like almost 100 miles an hour. But anyway, let's just say. Now let's see, what else do I need to know? We'll say that this angle, I'm firing this at an angle of 30 degrees. All right? And I want to know where they meet. Right, so these two are going to meet at some point. I'm aiming directly at this guy. All right, so I want to know at some point along the trajectory they're going to meet, and I just want to know where that is. All right, so first I want to find the time, and to find the time at this point, I just say that the x is equal to vx times t, because I know x, that's 10 meters. I know vx, that's 40 cosine of 30, and so I can solve for t. 10 over 40 cosine 30. I get 0.29 seconds. All right, so that's my time. That's the time required for the water balloon to travel this 10 meters. Sometimes it depends on the information that you have, there's no motion problem, but if you have your x range and your x velocity, it's really simple to get the time at that point. But I know that my water balloon reaches this point at 0.29 seconds. And so now I just want to know what height does this guy fall. So if I call this y naught equals 0, I want to know how far does he fall in that time. So I can say that y equals y naught plus v naught yt plus 1/2 ayt squared. What is my v naught y for this guy? This is the guy dropping out of the window. It's 0, right? He has no y velocity. So I get rid of a couple things. I get rid of this term and of this term. So this is just going to be 1/2 times -10 times 0.29 squared. I get 0.42 meters, or negative 0.42 meters. That means that guy drops 0.42 meters. So I just want to verify that that actually is the position of the projectile. And so I can say the same, but now for the water balloon, v naught yt plus 1/2 ayt squared. That's going to be 40 sine 30 minus 5, or excuse me, that's 0.29 minus 5.29 squared it's 5.8 minus I get 5.4. All right. Why do those numbers not match up? They're measuring, I have different coordinate systems for each. What's the problem here? I get 5.4 for the projectile, and I get negative 0.42 for the guy. What's the problem? Different starting points, right. So for the balloon, I'm calling this y equals 0. So for this, I'm calling this y equals 0. So I need to find out what is this distance, and then I can determine actually where they are on relative to one another. So if I look at this triangle right here, I have a triangle, 30 degrees, 10 over here. I know that the tan of 30 is y over 10, and so I can solve for y. That's 10 tan 30. It's 5.8 meters. All right, so this guy was at 5.8 meters when he dropped, and then he drops 0.42 meters, or let's call it 0.4 meters, so he drops to 5.4 meters, which is the same as what we find right here. So they go to the same position, and then they hit. You just say that this guy is 5.8 meters above the ground. So I say 5.8 minus 0.4, which is what we found right here. And so his position relative to the ground is 5.4 meters, which is the same as what we found for the water balloon. Right. Right. If you wanted to show that it's always true, is that what you're saying?
Yeah.
Yeah, you could do that. that as well. We're not going to do it here. That should be good. Okay. You want to see? Give me just a second. I'll find it on YouTube. It's kind of cool, actually.